Today we're going to be talking about common logarithms, and it's kind of the culmination of everything that we've been studying in this chapter. So first, when you have no base on your logarithm, when there's no number written there, that means that's an implied 10. So log base 10 of 6. Our calculators only use two logs, log base 10 and ln, which we are going to study later on in the next section. Okay. Oh, hey, look, it says it right here. Log 10 means log base 10. So in your calculator, all you have to do is press the log button, which is the fourth button up from the on button, 6 and enter, and you should get that decimal. Literally just typing in your calculator. So now try this one on your own. All you have to do is log 0.35 to the nearest 10,000. So log 0.35, enter, and let's see what our answer is. That's what you should have gotten for your answer. Okay, now we're going to be able to do other bases in our calculators because we don't just deal in base 10. This is a very important formula. I cannot tell you how many students I say, what's the change of base formula? And they look at me like they've never even heard of this. So this is a super duper important formula. So your log, okay, you can change any logarithm to a new base by doing log of any new base you want. Typically we use base 10 or that ln that we were talking about over log of the same base of whatever your base used to be. So the example, log new base 10 of 11 divided by log new base of whatever your old base was. So express log base 5 of 140 in terms of common logarithms. Then round to the nearest 10,000th. So I usually look at it like this. Log base 10, just go straight across, ignore whatever your base is. So log of 140. I went straight across, draw a line. Divided by log, since I'm below, the base is a little bit below, that's how I remember what goes where. So log of 140, straight across, that goes on top. All those numbers are in a larger font, so they're on top. The 5 looks like it's a little bit lower, that's why it goes in the denominator. Now type this in your calculator. Make sure when you type this in your calculator, you're closing out the parentheses. Some calculators will put in a parenthesis for 140. Close out that parenthesis, and then make sure you also close out that parenthesis. When I did this, I got 3.0704. Okay, our next example. There's a reason we learned logarithms. Logarithms help us solve for exponents. This is super duper important. This is why we learn logarithms. Logarithms help us solve for exponents. So really there's two ways you could do this problem. Okay, if you log both sides, so I originally have 5 to the x equals 62. If I log both sides, I'm going to leave myself a little bit of room. I log both sides. What you do to one side, you have to do to the other. Remember, you can bring down the x, your properties of exponents. So I can bring down my x, and I have x times log base 10 of 5 equals log base 10 of 62. We then divide. And type this in our calculator, and for x I get 1.2528. 10,000th is 4 decimal places. There's another way to do this. If you remember how to convert to a logarithm, log base something of something equals something. The base is the same as the base of your exponent. So 5 of x is equal to 62. Now, to get your answer, just type that into your change of base formula, log 62 over log 5, which is what I have here. So it ends up being the same thing, just whichever way makes better sense for you. Okay, again, we found logarithms so that we could solve for exponents. I cannot write 4 or 12 in the same base. That's the first thing you want to check. Check and see if you can write them in the same base. I cannot write them in the same base, so therefore we log both sides. Remember, when I log both sides, that allows me to bring down this exponent and put it in front. So I have 3x minus 1 times by the log of 4 is equal to the log of 12. Now, divide by what's out in front. So I get 3x minus 1 is equal to this crazy logarithm. Find out what that is. That is 1.792481125. I want us to be the most exact. So use that previous answer feature in your calculator and say 3x is equal to 1 plus that previous answer. So 2.792481125. Now take that previous answer and divide by 3. So here we then get 0.9308. Logs solve for exponents. Okay, remember that. This is our answer. Just reminding you, logs solve for exponents. Now this one's a lot more complicated, and I'm going to try and simplify it a little bit for you guys. Log both sides, again, like we did before. Remember, logarithms allow us, by our properties of logarithms, to bring down that exponent. I screwed that up. Sorry. Okay. Bring down my exponent and left with log 3 equals, bring down your exponent, x plus 1 times by log 8. Now, what I recommend you do is write these as decimals to 4 decimal places. So we have 7x plus 4, log 3 is 0.4771, log 8 is 0.9031. At this point here, what I would recommend you do is just work with decimals. Distribute it through. Now you're just working with decimals. You need a calculator. So just working with my decimals. Zero nine zero 3 1. I'm going to subtract this term over to that side and get 2.4366x. I'm going to subtract this over and the 1.9084 and get negative 1.0053. Now divide and I get negative 0.4126, and that is our final answer. Okay, again, remember, logs solve for exponents. Okay, that is it for today's lesson. Please make sure your lesson summary and lesson questions are submitted through the Google form below this video on Schoology on time.